So we are back with 1-5, exploring square roots and irrational numbers, and we're going to talk about a perfect square. So a perfect square is a whole number that can be named as a product of a number with itself. So example would be 81. 9 times 9 equals 9 squared. To do what we're going to do from here on out, we need to really know the perfect squares. And by the way, I'm on page 11 of your notes, your note packet, if you need to find it. So we need to know about these perfect squares. And perfect squares are essentially just like 1 squared, which of course means 1 times 1. And 1 times 1 is 1. So 1 is a perfect square. 2 squared is, of course, 2 times 2. 2 times 2 is 4. 4 is a perfect square. So what I want you to do is I want you to keep going. So 3 squared, I'm going to write them out. 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. I forgot the equals there. Let me go back. 11 squared, 13 squared. Oh, how about 12? Whoopsie. Mrs. Smith can't count. 12 squared, 13 squared, 14 squared, and 15 squared. And that's probably as high as I really think you should know. But these are ones that you need to commit to memory. So what I want you to do right now is go through and do each one of these and find the perfect square. So you do 3 times 3, which is 9. You do 4 times 4, which is 16. And I want you to pause the video and go ahead and finish filling this out to 15 squared. Now, remember, you can use your multiplication table to help you with the math if you need to. That's always available to you. All right, so pause the video and get working. All right, so from here on out, hopefully you said that this is 25. That's a perfect square. 36, 49, 64, 81, 100, 121, 144, 169, and 196. And last but not least, 225. Those are the ones that you really should start to commit to memory. You, again, always have your multiplication table available to you, but really start to think about it. Now, what I want you to do now is in your agenda book, find your multiplication table. And I'm kind of spanning down because I have a copy of mine right here. And the perfect squares you can see, and of course, perfect squares are rational numbers. We'll talk about that eventually. But perfect squares, I highlighted in this yellow. So I'd like you to do the same in your agenda book. Find a highlighter and highlight all the perfect squares in yellow. So 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, 4 times 4, which is 16. And of course, it makes this beautiful diagonal. The book keeps going all the way up to 20. We stopped at 15. But you kind of get the idea. So highlight now. So pause your video and find a highlighter and highlight your multiplication table in your agenda book. It's gonna help you in the long run. All right, so now, once you have done that, I'd like you to now turn to page 12 in your notes, so the very next page. So we talked about perfect squares. And so now, that's the question. So page 12, the question is the square root of 25. Well, remember, square roots are the same number times itself equals 25. So what number could we plug in there? And of course, what number times itself equals 25? It is 5. If you didn't know, this is a perfect square. So you could go back to your chart, find 25, and what number, you can go either way, what number times itself gives you 25? Well, I traced it up and found 5. Okay, so 64. What number times itself equals 64? So again, if you didn't know, you could find in the yellow 64. It's kind of hard to read, but right here it is. And then you trace it up or out, and you can see that it's 8. And so your square root of 64 is 8. Okay, so same thing, 100. What times what equals 100? And it's got to be the same number because that's what square roots are. So 100, find 100. Here it is. Trace it up, and it's 10. All right. Give you a second, pause the video, do the next two real quick. Okay, so you should have found out that number 4, you're back with us, the square root is 12, and number 5, the square root is 16, but I want you to notice something. Did you see that negative on the outside? That negative on the outside, we have to keep track of. And so that means I'm going to make this negative 4. So my square root is a negative 4. So the square root is on the outside. Now, let's think about this. This really means, because it's on the outside, it really means a negative 1 times, and I'm going to just put a parenthesis because smushed together means times. What times what equals negative 16? Because it's on the outside. So 4 times 4, of course, equals 16, and then if you times it by a negative 1, you get negative 16. Now, I also want to bring up that you will never see a negative under a square root. Because let's look at this. How could you get negative 16 with the square root? Well, I have to times the same number by itself. So the same number by itself, negative 4 times negative 4, does that give you a negative 16? No, it gives you a positive 16. So there's no way, if it's on the inside and you have a negative number, it's possible, because there's no way to take the same number and multiply it by itself and get a negative number. It's not possible. Okay? All right, so now you can see for number 6, we kind of take it up a notch a little bit. Now I have a fraction under the square root. But what you can do when you have a fraction under the square root, you can think of each of these individually. So you have the square root of 1 and you have the square root of 16. The square root of 1 is 1. The square root of 16 is 4. So my answer would be 1/4. So you just look at them individually. Okay, so here, same thing. It's a fraction, but split it up. The square root of 9 on top, the square root of 100 on the bottom. The square root of 9 is 3. The square root of 100 is 10. So my answer is 3/10. Okay, so moving on, and I keep going, I'm going to give you a few more. So you write a few more in here. So number 8, the square root of 289. Number 9, the square root of 49 over 225. And number 10, the square root of 361 over 400. So again, stop the video, try it out and see what you come up with. All right, hopefully you're back with us and you should have discovered the square root of 289 is just 17. Here, again, I'm gonna gonna make this maybe a little bit smaller so I can squeeze it in there. So I'm gonna do the square root of 49 over the square root of 225. Look at them individually. Square root of 49 is 7. Square root of 225 is 15. Same thing here. Look at them each individually. Square root of 361 over the square root of 100. Square root of 361 is 19. Square root of 400 is 20. And there you have it. Perfect squares. Getting familiar with these. And then doing square roots, whether it be a number, it has a negative sign in front, or a fraction. All right, good luck.